From the beautiful studios of Way Happy, this is Mr. Meyer and 2-1 conditional statements. So we are going to continue on with our road of vocab. And you're like, more vocab? Yes, more vocab. What is a conditional statement? A conditional statement is a statement that is made that has a condition really in it. And it's in the form of if then. Like if this, then that, right? So if you do your math homework, then you will get credit for doing it. That is a condition. And it has a hypothesis, which usually follows the if part, and a conclusion, which follows the then part. And the way we like to write it is right here. If P, then Q, right? Or P implies Q is the way math people will write this. So if we look at example 1, we see A is greater than 5 if X is greater than 3. I hope I just said X and not A. X is greater than 5 if X is greater than 3. So that is a statement. And the statement is if X is greater than 3, then X is greater than 5, right? And that is the statement. So that's what I would write. So the hypotenuse is the if part. So hypotenuse is if X is greater than 3. And the conclusion is X is greater than 5. And now they ask me to write that in the if-then form. So I will do that for the first one here if you want. I will say if X is greater than 3, then X is greater than 5. Now you could decide if that's true or false. And they don't actually ask us, so I'll let you just wonder. And I'm hopefully think you know the answer to that. Maybe I'll ask it in the quiz. All members of the soccer team have practice today, so we got to figure out which is the F and which is the then. And you can kind of just break it in, right? Like if you have practice today, then you're on the soccer team. Or if you're on the soccer team, then you have practice. That way sounds better. So again, I would say if you are on the soccer team, then you have practice today. Then you have practice. And I'm going to get sloppy here and not finish, and that's bad manners. So hopefully you have better manners. Here we go. If you're on the soccer team, that's our hypothesis. And then you have practice today. That's my conclusion. Now there's this thing called a negation, which you look up here and you see, hey, look, what's this all about? So that's just not, right? You put the word not in there. So you always had that friend, right? The one friend that you're always like, hey, it's really cold out today. And they're like, it's not cold. And you're like, really? Really? They're the negation friend, right? And you have them, right? Like, so here it is. You say, the car is white. And what do they say? The car is not white, right? That's your negation friend, right? We have them. We like them. They're fun to mess with. And they're fun to make us angry. What about this? It's not snowing today. What does your negation friend say? So not P. What do they say? They say it is snowing today. And you're like, all right. It's snowing. That's your negation. Why do I need that? I'm going to need it right now when I talk about things like inverses. So converse means you can switch the if-then parts. Right? So if you can take an if and a then and switch it, or if you just do switch it, that is called the converse statement. So the converse statement is if you switch the if and thens. The inverses is if you negate them both, then that is called the inverse. And if you scroll down a little bit more, you will see the contrapositive, which is not only the inverse, but also the negation. So it's the kind of the combined forces of those two, right? And so it's a converse and an inverse combined where you negate and you switch. That is called the contrapositive. So here we go. In example 3, they say, if you're in New York City, you're in the United States. So they want you to write a conditional statement. So you would say if P, and P is New York City. So if you are in New York City, then you are in the US. And then they say, decide if it's true or false. So if you're in New York City, are you in the US? Yes, you are. That is a true statement. What about the converse, though? The converse is if Q, then P, or Q implies P. So if you are in the US, if you're in the US, then you're in New York City. All right, what is that? Well, is that true or false? Well, I'm in the US, but I'm not in New York City. So I'm what we would call a counterexample to that. And so that makes it automatically false. If you can find one counterexample, you are golden. You have proven it is not true. All right, what about this? Not P and not Q. So if you're not in New York City, then you're not in the US. And let's see, again, I am in Livermore, so I'm not in New York City. Then I'm not in the US. Yes, I am. So another false statement. And then the contrapositive, where you switch them, you do the converse, and then you do the inverse, you negate them. And so you would say, if you're not in the US, which I am, then you're not in New York City, which means if you're not in the US, then you're definitely not in New York City. So that is true. So in this one, the contrapositive and the converse were both true. All right. We can do the same thing with definitions. Now, in math, we love definitions because we need things to be defined so we can use rules with them, right? And so here's one, like if two lines intersect and form a right angle, they are perpendicular lines. So if they form a right angle, then they are perpendicular lines. So that is nice to know. And you can also write the converse of this, right? If two lines are perpendicular, then they form right angles. And the converse is also true in this case. So that's kind of nice to know. Now, if the converse is true, and if the conditional statement is true, then those are called biconditional statements, and you can use the if and only if you want. Now, and I'll get to that probably, I think that's example 5. Example 4, is the measure of AEB 90? And I would say yes, it is. Why? Because I would say true, because the right angle symbol shows 90-degree angles. So let people know that you know what that symbol right there means, right? How about this definition? A, C, D are collinear. A and C and D are collinear. No, 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 no. Why not? Because D is not. Because D is not on line AC. Bam. Right? AC and CA are opposite rays. That looks like they are, right? Because one's going this way and one's going this way. They're exact opposite directions. But in the definition of opposite rays, you have to have the same endpoint. And this one has endpoint A and this one has endpoint C. That's not the same. So I cannot say they are opposite rays. So no, because, oh, I guess I already didn't have to say that, but because AC and CA do not have same endpoint. And that's in the definition. The same. And that's why definitions are so important in mathematics, right? This endpoint is A, this endpoint is C. That's not the same. It's obvious and we all see it, but by definition, that's a lie. There's the contrapositive, which we already talked about. And then last but not least, rewrite this as a biconditional statement. That means, again, a biconditional statement is when the condition and the converse are both true, then you can write it as one statement. And the way you write it is if and only if. And it goes like this. It's like P, Q, right? And that means if and only if. If and only if. Right? That is the definition of a biconditional statement. And so two angles are complementary, then their sum of the measure is 90 degrees. So then I could write that by saying two angles, right? I don't have to say if or anything yet. Two angles are complementary, complementary if and only if the sum of their measures their measures is 90 degrees. And right, that's definitely true. If your sum is 90, you're complementary. If you're complementary, then your sum is 90. Those do go both ways. So therefore I can use if and only if, and I'm done. Another way people do that, by the way, is IFF. You might see that. That also stands for if and only if, because math people are always trying to abbreviate. All right, kids, that's it. Stay happy.